I have too many tabs open and my computer's not.
Yay, tabs.
Actually, it might be this hop-in thing. Okay, is anybody on that stream? Is it working?
I am on the YouTube website, and it says, okay, it's turned into something else. 1 second. Okay, I see myself.
Cool. It looks like it's live.
All right.
Okay, so does somebody want to share that?
Sure.
I turned off hop-in because it was DOSing me.
So, okay, there's something wrong with hopping, and we are now trying to solve the problem. We are trying to move the audience to Zoom and also YouTube. Just wait a minute. We are so sorry.
And this is the popped out YouTube chat if y'all want to put that on your screen and follow that.
So now we are confirming that our audience can see us in the YouTube link.
Mm-hmm. Oh, Cara, I love your background. Wait, what's the thing?
So cool.
Oh, it's like it's like the no, it's not the castle in the sky. So
it is.
It is
a castle.
It is. It is the castle in the sky. It's just got
like the one from Laputa Castle in the Sky, the movie.
Yes, exactly.
Okay.
Nice.
It looks okay. I mean, it looks different, but maybe that's because it's abstract artified.
Stylized.
Yeah. You see the like robot dude.
Oh yes. Okay. No, that's good.
Yeah, it's definitely the real deal. And you got to have the ETH logo. This is I take, I used to take photos and add ETH logos to them.
Oh, did you do that?
Yeah.
Nice.
Well, I did the ETH logo. I didn't do anything else. All of the abstractification, all the artistic judgment, that's all other people. I just like added some lines.
Okay.
Oh, maybe we should pin another message instead of please go to session here. Please go to YouTube channel from YouTube.
现在可以开始了吗？9:20是吧？是吧 ？OK.
Okay, starting at 9:20.
Yes, we will start at 9:20. So we tell you get it.
Cool.
We are sharing all the YouTube link in the Chinese WeChat group. So it may take 8 minutes to propagation.
I guess for the people who in China who can't get on YouTube, would it make sense to just like record the thing and put that up as a file?
I'll click record now and then give it to y'all, and then y'all can edit it and put it up however you want.
Okay.
I'm also going to postpone our our next call for 20 minutes.
Scheduling.
MP.
Mm-hmm. No, this feels great. This is like one of the first time we've had one of these like extremely stressful, let's figure things out really quickly situations. Like, remember the Shanghai DOS wars?
Oh my gosh. Good old times.
Yeah.
Oh God, I'm just waiting for the equivalent of Shanghai DOS wars, but with optimistic rollup. Very scared.
I have some sort of kernel task that's taking 200% or taking 2 CPUs right now. I don't know why.
Is it sure it's not just a node or something?
I don't think it's a node.
That would be 3.
No, I have I got like a little home server recently, so I have nodes on that instead of my laptop, which is really nice.
We've got 5 minutes. Vitalik, people are saying hi.
Oh, excellent. Were they saying hi in the YouTube?
In the YouTube, yes.
Okay, hold on. Let me open up that YouTube link.
Someone in Hopin said you're like Tony Hawk.
I'm like what?
Tony Hawk.
Who's Tony Hawk again?
The skateboarder.
Oh, I see. No, I was thinking, okay, is that like Huckleberry Finn or Tony Stark or something else? And no.
Tony Stark.
Have you been watching Game of Thrones?
Oh.
You've been talking about Game of Thrones a lot recently.
Oh, yeah.
Let's see. Oh, cool. I can see the YouTube. Let's see. Vitalik and Danny get virtual backgrounds too. Hi, Vitalik. Hello,
I have Octopi behind me. That's good enough, right?
Yeah. Hi, Weisha, 你能看到我的评论吗? Yes, I can see. When do we expect to launch the final multi-client test? Okay, yeah, we're getting questions. Oh, cool. Goose got, oh wow, 3 languages in the chat. This is awesome.
What is the third?
German.
Oh, I see.
Wait, what? Okay. Some other language in the comments I don't understand. What
But seriously.
Oh, extremely soon.
I need you to buy me some time. We're streaming though. Sorry. Hello, everyone.
Get the hard questions out of the way.
There, one light.
Hey, Ganya. One life extension.
like
after ETH2, I think. I loved the early comments on your wine rack. People were pretty fascinated with your wine rack for a while.
Oh, I see. Yes. The thing that I did not even realize was a wine rack until other people told me about it.
What did you think you're supposed to put in that? Books?
I don't know. It's just like a decorative thing.
You could hang coats on it, maybe. Oh, you could put shoes in the cubbies.
I don't know. Maybe it's like an armory, so like you put like bows and arrows and spare shells in there or something.
Yeah, I guess you could probably lean guns like a shotgun in it. Although that house is in Canada, not the U.S.
Yeah, exactly.
Oh god, Vitalik Hoygat. Okay, I feel embarrassed. I don't actually know how to pronounce Dutch.
Good evening. Oh wow. Oh, talk about DAO. I wonder if it's in the DAO.
Yeah, we could talk about that. Okay, so I think it is 0920. So should we just start?
Yeah, we're gonna have that other call in like an hour from now. So I think I'd rather start.
Okay.
Okay, so we'll start now. So hello everyone. Good afternoon.
Are y'all having issues hearing? Yeah, okay. We're having connectivity issues with you, unfortunately.
Apparently your Dutch accent is pretty good, Vitalik. That's very exciting.
Where?
Decent attempt to speak in Dutch.
So is everything okay?
Yes, we can hear
you. Okay, so let's start. So welcome to the very first event of Ethereum 2020.
The audience, we're having technical issues with the latency. We could talk.
Yeah, let's talk.
Okay. Cool. We're here to talk about, I think, Ethereum 2.0, but also just about scaling out Ethereum, which Carl, although is not involved in the core protocol scaling, is doing some really exciting scaling work. For those of you that don't know, Ethereum 2.0 is a major protocol upgrade to kind of fulfill the original vision of like a fully decentralized and scalable Ethereum. There's two big things that we're doing. One is we're moving the consensus mechanism to proof of stake from the current proof of work model. And the other is that we're moving into this sharded model where the consensus can handle many parallel blockchains, so many parallel versions of Ethereum, all operating under the same consensus and all able to communicate and be aware of each other natively. We're rolling that out in phases. Phase 0 is what is currently in testnet and what all the excitement is about. Phase 0 is really rolling out the core of that proof of stake consensus that provides like the backbone for the rest of the sharded infrastructure that we're rolling out over the next chunk of time. Stuff is really exciting. You can get involved today with testnets. Check it out. Altona is the name of the testnet today. And as somebody asked, when is like, well, we have many clients, we have many teams working on this, and someone asked, when is the multi-client testnet? And I've been talking to client teams recently. The current smaller testnet is going really well, and we plan on rolling the next larger multi-client testnet. I won't call it the, because if there's incidents, we might have another one following. But if all things go well, it will be the. In a matter of weeks, we're talking about early August. I'm not afraid to say that because it's actually coming. But yeah, that's kind of like the overview. What's going on in ETH 2.0 today. Vital, do you have anything to add to that?
No, and I think that definitely all makes sense. And in general, it's been the kind of process that we're going through is very similar to the process that we went through around 5 years ago. So this was back when we were launching ETH1 for the first time back in 2015. And we had this kind of roughly 4 months long period where we had these multi-client test nets, and we opened them up to bounties, let people play around, let people send all kinds of crazy transactions on them. And at the beginning of that period, things were definitely very tough, and there were times when there were just consensus bugs being discovered between kind of the different clients every week, but then it just kind of stabilized over time. And when we became kind of confident enough, and when the thing just stopped having consensus failures for an entire month, then we said, okay, now is the time, and we're doing it. And we ended up launching ETH1. So I guess in general, I'm definitely expecting a fairly similar process for ETH2 Phase 0 as well.
Mm-hmm. Which clients were on that early multi-client testnet in ETH1?
There was Guess, there was CPP Ethereum, aka Alice 0, and I think Python was trying to be connected, but never super successful because Python's slow.
What? So you've been through the launch of ETH1 and now working on this launch of this major upgrade called ETH2. What has been unexpected in this process? What has been harder in this process? There's a lot of learnings that we've taken and tried to use to make this process better, but what in this new proof of stake process has been different or more challenging?
We definitely have a lot more eyes on kind of every single part of the protocol spec, and we kind of take the protocol spec very seriously in a way that we didn't in ETH1. In ETH1, the research team itself was largely myself and Gav, and of course Gav did end up writing the yellow paper, but we didn't really have this kind of really sophisticated thing. We have an executable spec, and then we have all of these. We did have test cases, and we did have audits, so there was definitely a lot of work going into it, but it definitely was significantly less, I guess, professional than this time around.
Right.
Yeah.
Cool. Based on the questions, I don't know, where do you all want to take this? I guess just in general, we got Carl here. Carl, Vitalik and I are working on scaling out the protocol in the medium term. It's a difficult task, and we have a road ahead of us. But Carl is working on scaling out the protocol through layer 2 mechanisms, through some very exciting mechanisms. Carl, do you want to give us a look into that?
Sure. I am into quick fixes. No, I'm just kidding. But no, in the short term,
complementary fixes.
You're right. Complementary, absolutely. So in the short term, even before some of the later phases of ETH2, there will exist a bunch of rollups on Ethereum. In particular, optimistic rollup. That is what I am working on. And in fact, we are also going through some of the kind of long, dreary roads of many, many bugs, and squashing them in our optimistic Ethereum virtual machine or optimistic virtual machine.
Carl, what's a rollup?
What's a rollup? Oh, what a great question. A rollup is a layer 2 scaling solution where you post all the transactions to Ethereum, but you do not execute the transactions on Ethereum. This has a great benefit in that Ethereum's computation is relatively slow, so you can actually fit a lot more if you don't compute it on Ethereum and you use some off-chain mechanism for this, computation of the validity of state roots. But in effect, what that does is it scales up on ETH1, something around, the random numbers that people say are like up to 2,000 transactions per second. There's like a reasoning behind it. And then when ETH2 comes around, the complementary bit kind of gets a little bit more visceral because Vitalik's classic estimate that I always reference is 100,000 transactions per second. So these numbers are just ballparks to get you your brain juicing.
I'm happy kind of going through the process justifying those numbers.
Yeah.
Sure.
Yeah. So basically, the way that rollups work, right, is that they get around a lot of the problems around kind of completely layer 2 protocols where almost all of the data goes off chain. And the way that they do that is they require just enough data to go on chain that kind of basically contains the information about just how to compute the current state. So this basically means that of all of the actual account balance changes, any kind of deployed contracts, any contract storage changes, like basically you need to put enough information on chain to just tell people kind of how to compute the entire state tree, how to compute like what everyone's balances are, what all the accounts are, and all those details. And it turns out that it's possible to kind of really compress that information. And the way that you compress that information is like, for example, one thing you can do is instead of referring to all the addresses by this long kind of 20-byte ID, if you have a tree and that tree contains, say, a million addresses, then you can just refer to them by index, right? Instead of saying like account 0x043F5C, blah, 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 you just say the 44th account. And so you're going to compress the information needed to represent an account into 2 bytes. And then for transaction values, like the amount that you send is normally, something like 8 bytes, but we can compress, right? So like, for example, most of the time people send like whole numbers of ether or like whole numbers of, times 0.001 ether. And so you can have like a couple of bits as a flag. And then if you're sending 35 ETH instead of sending this really long number of like 9 or 10 bytes, you would just send the number 35 and then a flag, right? So if you kind of combine a whole bunch of these different tricks together, you can set up a system where the information needed to just say, how much everyone's balances went up, how much different numbers in the storage went up, to maybe like 10 to 20 bytes per transaction. And in the context of ETH1, call data, so data in transactions is charged at 16 gas per byte. And so 10 to 20 bytes corresponds to, 160 to 320 bytes, right? Gas. And we can be conservative. We can say, 400 gas. So then let's say you have 400 gas based kind of on-chain per transaction. Each block has 12 million gas. 12 million divided by 400 is going to get you to 30,000. And 30,000 divided by the block time, which is 13, gets you to somewhere around 2,300 transactions per second. So in ETH2 now, of course, it's sharded, and so there's a lot more data. And given kind of current statistics, we expect the data capacity of these two chains to start off somewhere between 1 and 3 megabytes per second. And so if a transaction is 20 bytes, then 20 megabytes per second or 2 megabytes per second becomes 100,000 transactions a second. So that's roughly how the math goes, right? So it actually assumes that everyone is using rollups and that these systems are kind of completely full for rollup transactions. If, of course, 50% of users are using rollups on ETH1 and 50% of users are using other things, then transaction capacity would only be, of course, like 1,200 and some lower number if those transactions are inefficient. So that's kind of where the numbers come from.
Thank you. Here, we had some questions collected before. Yeah. So what advice, we're talking about two scaling solutions that are going to make a huge impact on Ethereum over time, but obviously these things in different capacities are still in the works. Actually, we have some ZK rollups for transactions for financial, just like user-to-user balance transactions on mainnet today. Optimism and things like other optimistic rollups are in the works. ETH2 is obviously in the works. What advice would you give to developers building applications now in the context of scalability coming? What should we be thinking about? How should we be approaching these problems? If I want my application to be future-proof, I want my application to fit into the future of Ethereum in the context of rollups, in the context of ETH2, what decisions should I be thinking about and making today?
That is a great question, and I have a lot of opinions. So there are many different kinds of developers, and so I can't really give, all across the board advice. However, if you are, for instance, a smart contract developer that is, clearly is feeling the pressure and needs to scale because Ethereum is just filling up and the gas prices are getting really high, and you are, quite concerned, but you already have a bunch of smart contracts, you understand solidity, all of that kind of stuff, then I think one very important thing is you can rest assured that the scalability for your smart contracts will be handled to an extent in the background. So in other words, the kind of, as a programmer, you are writing this code and it expresses some kind of program. And it is in some ways on the scaling solutions that are building for you to basically take what you wrote as your code and make that work better and more efficiently and scale up. And so things that you can do that just like to kind of think about the fundamental limits of scalability of your smart contract, you can think about what in my smart contract can I parallelize, what in my smart contract what are the different properties of my smart contract. Now, if you are, dying for scalability now, or if you are, you have a different use case that's not quite using tons of smart contracts, the answer is definitely vary, right? You can, if you are really, really dying for like high transactions per second and you need to really heavily optimize, then yes, go use an optimistic or a ZK rollup, optimistic rollup, or you can build your own even. But I think that for a large percentage of people, it's going to be a kind of gradual thing that the tooling gets better. And don't worry, what you write today is not going to just be, trashed tomorrow.
Can you talk a little bit more about how you see the user experience in the context of layer one and potentially many layer twos, and how all these things might connect, and how maybe as a developer experience, but also just the user experience, like how am I going to think about assets in this like multi-layered world?
Yeah, it is very interesting. And from there, like we'll have multiple layers, right? We'll have multiple rollups. We'll also have multiple shards, and we'll have multiple execution environments. So this like multiplicity is going to be kind of the standard and is going to become more and more prevalent. From a user perspective, one would hope that some of this stuff is abstracted away, right? One would hope that you just you have your wallet and you sign your transactions and you view your balance. On the back end, how that works is kind of another story. And essentially, from a kind of smart contract developer's perspective, one way to prepare for this multiplicity is actually by writing your smart contracts in such a way that they are portable across different systems. So I think that will become much more important. All of this, stuff about, whether it's on-chain governance, whether it's just, redeploy your whole smart contract system, we will have to be thinking about the fact that different chains may suffer from different congestion levels at different times, may suffer from, service outage, whatever it may be. And it will be like a more of a common practice to actually migrate between systems. So this is, it's quite exciting though.
Mm-hmm. And one more. Do you think that the primary environment that people will operate in a handful of years will be in a roll-up environment? Even in the context of ETH2 existing?
I think that there is a massive benefit for different designs. And like when you say roll up, it's really just a catch, a term that catches a huge amount of designs. In particular, the reason why I think that there is a space for what is, commonly referred to as rollups is because rollups can actually scale past the kind of one shard limit inside of a synchronous environment. So there's this talk about, okay, Ethereum 2, oh, what are we going to do? We have to use asynchronous programming techniques. Number one, those aren't, the end of the world. But number two, the programming, the synchronous programming paradigms will be preserved inside of rollup chains. And they can be preserved inside of rollup chains, of course, while maintaining massive scalability that is, scales much more than just, a single shard or ETH1. And also, of course, preserves the Ethereum security model. So there's definitely a place for all of these things.
Cool. Thank you. Is Alec giving an add there?
No, and I generally agree with all of that. Carl speaks so well.
Yeah, one more follow-up, Carl, just because I'm here to pick your brain. I'm actually curious about these things. Okay, we have say we have one execution shard and we have a ton of shards for data. Can we have, and I think I know the answer, but you probably thought about this more. Can we have a single rollup that leverages the data of all of the shards, or would you have to have separate rollups?
A single rollup that leverages the data for all the shards, 100% possible, number one. Okay, so, and here there are also a number of, okay, I'm sorry, I can't help myself. So that rollup can be a ZK rollup, right? Where you leverage the data for all of these shards and you're, it's computing these fraud proofs and, proving validity, that's great. It can be an optimistic rollup using, optimistic rollup techniques. And both of these, right, it's going to scale the, programming environment. But you can even do crazy stuff. And this is like questionable whether or not it's a rollup, depending on how you define it. But you can even leverage Ethereum shards in such a way that you actually use the different, committees to prove the validity of different state transitions, and then kind of like weave it all together into one, proof. So basically this is a underspecified description of a way to basically get what, Solana is, talks about with like no shard stuff inside of a decentralized sharded protocol like ETH2. So it's actually really cool. And that is like all native, using the native infrastructure for ETH2.
Yeah. And one thing you probably clarify is that the one sacrifice you're making is that you would need to have a kind of powerful node somewhere to be able to actually kind of process and keep up with that entire state. But like that, the things that they do, like they would either have to ZK prove everything or it would be fraud proven, and so like you can have a lot of infrastructure. They're going to prevent that from being a centralization issue the way it would be if it was that base layer.
Gotcha. Cool. We can shift it back a little bit to ETH2. I mentioned earlier that there's these phases of rollout and that we're in the midst of what we call phase 0, which is very exciting and honestly represents like a large chunk of the work. It represents the foundations of these ETH2 clients and like really a lot of the complexity of this consensus mechanism, the finality mechanism and block building mechanism in that phase 0. But we do have some other phases and people have been asking about them. So I guess I'll enumerate them. We can talk a little bit about some of the gains for the Ethereum community along the way. So phase 0 is really like, it's for validators. It's to bootstrap this new consensus mechanism to make sure that it works well in a production setting. Real ETH is used and real ETH is gained and can be lost depending on performance. And really like phase 0 is this like sanity check mechanism to like get the core of it in place and kind of begin to build on top of this new consensus mechanism. Phase 1 is what we call it's where we add shard chains, and where we add shard chains that are just considered, they're just data. They're data in the sense that they are blocks, but they don't have they don't have user level interpretation of like as transactions. There's no state and things applied to these. But with a lot of this data, we'd like to see roll-ups and other kind of high data consumers begin to use this data layer. And we have some things in the works on how that can be done. Vitalik, you want to talk a little bit more about data availability and just...
Sure. So, and as Danny mentioned, and ETH2 rollout has multiple phases. Phase 0 basically just introduces the proof of stake chain. Phase 1 starts sharding, but it's not actually verifying transactions. It's basically just verifying the fact that there exist blocks that have some amount of data published inside of them. And the idea here is basically that the role of the chain and kind of the thing that the chain is verifying is just that there are these blocks and these blocks contain data, and this data actually is part of the chain, and you can get the data if you want to, right? So the reason why this is useful for rollups is basically because the chain provides what we call this sort of data availability guarantee, right? So the data availability guarantee basically means that there is kind of a common knowledge that for a particular piece of data, which might be represented by a hash, might be represented some other way, if anyone wants to get the data, they can, right? And this kind of guarantee is really important in a lot of layer 2 protocols, basically because it ensures that if someone publishes a message that says, oh, look, here's a piece of data and here's something I'm claiming about what the data does, then you actually know that, for example, if they did something wrong, then anyone else actually can go and actually can download that data and actually check it, and if the computation is incorrect, like for example, make a fraud proof, right? So this is how optimistic rollups work. Also, making sure the data is available ensures that anyone has the data, and if that data contains like state transitions, so like as I talked about rollups before, like rollups have to put kind of information about state transitions on chain, then anyone can actually download that data, which guarantees that anyone actually can kind of construct the current state and join the system as a participant, right? Which is really important for these systems as well. And so basically, because for, as I said, somewhere between 1 to 3 megabytes per second of data, then this data layer can be used as a backend for these kind of very high capacity rollups. Now, so that's phase 1. Another thing that people talk about less that's also coming in phase 1 is light client support. So phase 1 has some more light client kind of friendly features. And theoretically, you can already use ETH2 as a kind of part of a light client for ETH1. So the ETH2 chain kind of has a one-way link going to the ETH1 chain, which is used for processing deposits. And this also means that if you have consensus on an ETH2 block, you also have some consensus on kind of the ETH1 block that it points to, right? And so if you want to have a kind of a lighter weight Ethereum client, then you can use the ETH2 client, it points to an ETH1 block, and then you might only have to verify, say, 1,000 kind of actual ETH1 blocks going forward from there, right? So this could be useful for making mobile wallets that are not reliant on a single server or other applications like that. And then after phase 1, we have this kind of very important phase that we call the merge, right? So this is where ETH1 and ETH2 kind of finally get combined together. So what happens in the merge is basically that we take the state of the ETH1 chain, and you take the state root of the ETH1 chain. So this is kind of the hash of this big database that contains all of the accounts, all of the smart contract code, all of the smart contract data in ETH1 as of that point in time. And you take that and you just kind of transplant it into, kind of move it into the ETH2 system. And from then on, all existing Ethereum applications continue, except instead of being processed by ETH1, they're processed by ETH2, right? So from an application developer point of view, kind of very little actually changes. Like you might see kind of an interruption, like a period of maybe 1 or 2 hours where there aren't any new blocks, but otherwise the application worked before inside of ETH1, and it'll keep working later inside of ETH2. where kind of the same rules get processed, the transactions get processed in the same way, except it's the ETH2 system doing it instead of the ETH1 system. So
and even
that's
an important note is that the way that we're thinking about these like the actual like software architecture is that we have these ETH2 clients that handle the core consensus for this like new sharded proof of stake consensus, and then we have these ETH1 clients that are very good at processing user level transactions and handling state. And we plan on kind of combining these in a little communication protocol. We're actually prototyping this today. But the really nice thing is that if you leave the ETH1 client stable and you leave the API endpoint stable, that a lot of the, as long as you just redirect your like developer tools and things to this API endpoint, you actually have like most of the developer experience kind of just like captured and handled properly in here. And so like these little things like are important for us to like enumerate and figure out to make sure that the developer experience in this migration is as smooth as possible.
Yeah, and +1, the developer experience is so critical. And as much as we hate the Ethereum developer experience, it's the best smart contract developer experience out there. And so
as they say, Ethereum is the least developer friendly blockchain out there, except for all the others that people try from time to time.
Right.
Exactly.
People complain about the things they use. They don't complain about the things they don't use. Yeah, cool. And then so we have this merger. This is the core of this this ETH2 thing. There's a lot going on. There's potential things after in this phase 2 that we talk about, but really the integration of the existing Ethereum chain into this new consensus mechanism with a highly with a secure proof of stake layer and a highly scalable data layer. Like this is like one of the main driving force today. But we have this other thing that we call phase 2, which is we have all of these shards. At phase 1.5, at the merge, we have ETH1 as a shard, and we have a bunch of data, which we expect developers to figure out really fun ways to use. But there's no additional computation on these shards. So phase 2 is the adding of more state and more computation to either some subset or the entirety of the rest of the shards. Vitalik, do you have any comments on that one?
Yeah, so phase 2 basically will be kind of expanding the sharding to not just cover data, but also actually process transactions. And so you'd be able to have kind of native for kind of level 1 transactions on any of these shards in Ethereum. In terms of what that would look like, it's not especially complicated. Like the kind of the default model that we'd expect at the beginning is basically just have a kind of 64 copies of a system that's basically the same as ETH1, except these kind of shards will also be able to talk to each other, right? So this cross-shard communication, this is another really important thing. So basically, if you have a transaction in one shard, then it can kind of send a message, and that message can then be kind of later processed by another shard. Basically, you would kind of include into the other shard a Merkle proof that proves that the first shard created this message, and then the second shard can process that message. So this can be used to transfer ETH between shards. It can be used to transfer assets and smart contracts between shards. One important limitation is that cross-shard communication is going to be asynchronous. So what that means is that it's not like what you can do is have a thing happen on shard A, that thing on shard A sends a message, and then later that message gets processed by shard B, right? The thing that you can't do is to have kind of multiple steps of communication between different shards within one transaction, right? So what you can't do is say, oh, let's do this thing over in shard A, and then do this other thing in shard B, and then do this other thing in shard C, and then see the outputs of all three of those things, and then immediately, based on those outputs, do something else inside of shard A. So synchronous communication, so kind of where you have activity happening on multiple shards as part of one unit, which is something that you can do in ETH1. Like you're not going to be able to do that across multiple shards in ETH2. You can still do that within a single shard. And you can still do this thing that I call yanking, where you kind of first move a bunch of objects from different shards to the same shard, And then when those objects are on the same shard, you perform a big synchronous operation between them. And then if you want, you move them back as a third step. But like, there is a limitation to what you can do in a synchronously, basically. I don't think that limitation is going to be that bad, but there are some applications that it makes harder. So like flash loans, that kind of one transaction and that kind of crazy arbitrage things, a lot of that becomes harder. And
not impossible, but just like
yeah,
more limited in global state and how you can interact with these things.
exactly.
And in your rollups, you could still have some fun flash loan games.
Yep.
Yeah. And note that the like when Vitalik just casually mentions like yanking, right? That whole process needs to be programmed into smart contracts. And so that means that your smart contracts will exist on like multiple different, one could call it domains. And so this, thinking about how to either migrate a contract to a different, whether it's a shard or a roll up, or thinking about how to, just allow your users to choose what roll up, shard, whatever they want to be on. Those are going to be, more and more the question as a smart contract developer.
Yeah, and there's like potentially new standards and updated standards that might help facilitate this. For example, like the notion of an NFT rather than it being like tightly embedded into a parent contract, it being kind of like a derivative contract that you have control over and kind of move around the system, which certain types of these things and thinking will evolve, I think, over the next few years. We're not at time, but I think that we did want to open it up to questions. Has there been any questions, Vitalik or Carl, that you've been seeing in the chat that you'd like to address, or does anybody in the chat want to throw up some more questions?
Hold on.
There was one question that's somewhat interesting. That was from a while ago. It was, quote, if as an example, we take the Reddit plus Ethereum scaling proposals, some centralized parts might be needed to make it work. For now, at least, are you comfortable with that? And he said Vitalik / Carl, but I'm curious, Vitalik, not to put you on the spot.
Some centralized parts. I mean, I think that's like as a short-term thing, it's definitely fine. And even the roll-ups that we're seeing, like they have some like not trusted but centralized components as their first step.
What is the most promising? What do you think the most promising direction for the Reddit scaling in the context of like the next few months is?
Oh, yeah, that's a great question. You go first.
In the Reddit case, the thing they're doing is primarily just sending transactions of coins around, right? Like there is no fancy smart contract-based stuff that goes beyond that.
Minting.
Minting is the hard. I think really the hard part here.
Why would minting be hard? Like, isn't minting just a matter of one account starting with a Googleplex tokens and then sending them to whoever they want?
That should work.
I don't know. Yeah. I was talking to Barry. There was a conversation I was half following the other day where that was the
it should be doable.
Right. Like, because if you can kind of make your application work with just token transfers, then you can just put it inside of one of the existing ZK rollups. So either Loopring or ZK Sync that are on Ethereum mainnet today.
Yeah, and maybe you need to have a privileged account that can like update a Merkle root that people can mint out of or something.
Yeah.
Although you could do the Googleplex idea, and maybe that would be useful for some of these teams. But one random thing that I would note is like the Reddit scaling competition is an example of like the interesting space that we are in right now, because Reddit has already written smart contracts that work on Ethereum, work on a test net. However, they are just too expensive for mainnet. And so it's unfortunate that essentially, there's going to very likely be, if they want to scale immediately, there will have to be some switching costs between moving their system that functions one way right now to another system that functions another way. And then there may even be a switching cost of moving back, re-expressing their smart contracts in something like Solidity or in the EVM. And so one like question as a project that I think is like going to be very real is like, do I want to wait until, let's say the end of the year to, essentially get some level of scale for my Solidity contracts, or do I want to invest?
The end of
the year? Whoa. Or do I want to, invest today in kind of custom tooling? And in fact, there's a lot of reasons to, do the custom tooling, but I'm just so obsessed with the Ethereum DevX. I'm sorry, I just keep rattling on that. Yeah. Please forgive me.
Yeah. No, I'm just looking through other questions.
Is there a dependency of ETH2 phase 0 release on the ETH1 next upgrade? This is an interesting question. So ETH2 early phases of development have been strategically decoupled as much as possible from the existing ETH1 development and hard fork upgrade. So phase 0 it will be released with no consensus changes on ETH1, and in addition, phase 1 will also be released with no consensus changes in ETH1. This allows us to move very quickly and not be encumbered by the release schedule and development process of like a very valuable and existing chain. Only once we get this to phase 1 and really have like these core components proven out and built out and scaled out, will the development of these two things become coupled when we integrate ETH1 into ETH2. And it goes the other way. The ETH1 process will not be encumbered by the ETH2 process until we reach that phase 1.5, that merge. Yeah, any other questions in there?
I mean, there's a bunch of people talking about this MMMBSC scheme, which is a scam. So like if you participate in that, you will lose money. So like guys in the chat, please stop talking about it.
Nice.
Someone said, can someone talk about the dependency of ETH2 release on the ETH1 on specifically the BLS 12381 curve operations?
Wow.
So BLS 12381 is a new curve. We use BLS signatures in ETH2 to do some fancy stuff like signature aggregation to help with scalability and to help with like having a number of participants be able to participate. You cannot currently natively do this efficiently on the ETH1 chain, but there's an EIP to enable efficient computation here. Phase 0 is not, we don't need this on ETH1. It does add, like if we have the BLS curve operations on ETH1, it gives us a little bit of extra safety during the deposit operation. Come phase 1 though, if we have the BLS curve operations on ETH1, we can write an ETH2 client as a Solidity smart contract, deploy it onto ETH1, and at that point, if we have the BLS curve operations, we can efficiently use a ETH2 smart contract inside of ETH1 to learn about ETH2 and to leverage the data layer for rollups. This sounds really complicated. It's a little complicated, but if we do get that operation onto ETH1, it allows us to utilize the scalability of phase 1 before the merger. So it is an important one. I don't know the schedule. I think that people are interested in getting it out there, and I think that's very possible. In the next 10 months to see it on mainnet. But I don't think it's going to happen before phase 0.
Great. So I'm gonna jump in. Oh, hi guys. Let me turn on the camera.
Hello.
So anyways, we got some questions from Chinese communities. So the first one is DeFi. So people really want to know what's happening like after MakerDAO and the Kyber network. So what's happening and what do you guys think about DeFi? Yeah, go ahead.
And what do we think about DeFi? And DeFi is cool, and it's definitely one of the major kinds of applications that's happening on Ethereum now.
That's pretty general. The people want to know something. It's like go deeper. That's the name. Let's go deeper, right? Let's go deeper.
Right. Yeah. And I'm just wondering, like, what deeper things I should say about DeFi.
You know, I I only follow DeFi at service because I'm like deep in the
Right.
weeds with other things. But I sometimes I look at DeFi and I go, this looks like crazy financial engineering, which I think it is. But which in a traditional context gives me much concern, say in the Wall Street context. But I think a lot of the concern there becomes comes from the opacity of the financial engineering going on in Wall Street. There's not a lot of like visibility into like what these assets actually are, how they're interacting, and what's going on here. Whereas in DeFi, yes, we're going to have some magnificent disasters along the way because this is a grand experiment. But there's this incredible amount of transparency in like seeing the assets and understanding what is actually going on in this like engineered context. And so like that's what really excites me about it, is that it kind of like levels the playing field in this kind of financial engineering thing that's happening already in the world. It only happens with like the privileged elites, and it happens in a very opaque way, in which we get ourselves into trouble. So I think this like new decentralized slate is going to give us new opportunity here. But again, I don't have much to comment beyond that because I only follow on the surface.
Fair enough. What about you?
Yeah.
What about you?
And I guess one of the challenges with DeFi is that like, DeFi is a lot of different things, and some of those things in DeFi are great and really valuable. So like I think stable coins are really valuable, for example, and just being able to exchange between tokens is really valuable. And I really like prediction markets. But on the other hand, there are also kind of other applications in DeFi that are not very sustainable. So like, for example, when people talk about, yield farming and being able to get some like,
Right.
like 100% kind of interest rates every year, like those things are only possible basically because, Compound is kind of temporarily giving away tokens, right? So like when the ecosystem becomes mature, like I don't expect DeFi to be able to give interest rates that are like much higher than interest rates you can get in other places in finance, right? So like I don't expect kind of DeFi to be able to just be much better than traditional finance in those areas where traditional finance already does very well.
I think there's certainly
think
efficiencies in a decentralized context that might, there might be additional profits for end users that you couldn't necessarily find on Wall Street, but we shall see.
Mm-hmm.
Okay.
But not crazy yields.
Not definitely. So the next one is gonna be what's the effect on the miners after the change to POS? Sorry, it's my cat.
Mm.
So inherent in the change to POS is the us not using Ethereum not using proof of work anymore. So it's it would have a substantial effect. Obviously, there's a lot of hardware out there. There's a lot of miners out there, and so that hardware will probably go somewhere. I think there might see a lot of liquidation. It might be fire sales. You can get some hardware for cheap, but you also might see a boost in the proof of work on other chains. I can't fully predict exactly how this is going to play out. Vitalik, Carl, do you have some thoughts there?
Yeah, and I think part of it will be hardware going to other chains. Part of it will be gamers being really happy that hardware is suddenly really affordable. Part of it will be if we can get these zero-knowledge proof-based systems popular in time, then I could imagine some mining hardware switching to being zero-knowledge proving hardware. Like zero-knowledge proving is definitely this kind of very expensive kind of computation that's still very valuable in a lot of ways. And so if we can kind of, I imagine an ecosystem where kind of some of that hardware gets repurposed to that could be useful for a lot of people.
And hopefully a lot of the miners have a bunch of ETH, and so they can begin staking and validating for ETH too.
Yeah, I used to run a mining rig, just one, with the intention of just better understanding the protocol and stacking some ETH to stake. So maybe there's some other people that are doing that as well.
Hmm.
All right, so there's a question. Actually, myself really interested. So if there's, let's say if ETH2 launched, like maybe the end of, I don't know when, we haven't talked about a date yet. So maybe I think I should ask because people was wondering, right? So I think when we can officially launch ETH2 and also like when that time comes, maybe how gonna affect social media. So I know there's
Mhm.
some talks like rambling around the social media about the journalism and those decentralized media. So what's gonna look like after ETH2, like we are on social media. So what's gonna look like? TikTok, anything?
How's it going to affect social media from the standpoint of like people memeing it and stuff?
Yeah, and maybe that time, I don't know. So maybe just so interested.
I'm not on most social media. I'm on Twitter in like kind of a professional capacity. So I don't have my ear to the ground. I don't know how the young kids are using these things. I know they were pumping Doge recently, which is ridiculous.
Yeah.
But I can give you some insight into what needs to happen before a launch. Um, E2, we have many clients. We actually have 7 in active development. We have 4 on the multi-client testnet, 4 that are looking very strong that I'm excited about. This multi-client testnet that was recently launched is more of like a dev net. We started just with some the client teams and some EF people running nodes, and then opened it up to the public, and it's grown some. But we want to launch a like large scale public multi-client testnet. That's the thing that's in the works right now. We've seen pretty solid stability on the current multi-client testnet. So we need to launch this multi-client testnet. We're going to launch it with like mainnet configuration with at least 16,000 validators. We're going to have mainly the community running it. We're going to be running some nodes ourselves, but not a majority. And we need to see stability on this large-scale multi-client testnet. We need to give people a chance to run nodes, run validators. We need to honestly like put this in the hands of more people, because that's going to uncover potential like actual system bugs, but probably more so UX bugs. So we're going to have some UX refinement over this like larger multi-client phase. And if that multi-client testnet goes well, we need to run it for some amount of time. People are talking between 6 and 12 weeks, depending on who you talk to and the day. At the same time, simultaneously, we have a number of like client audits going on right now. So external professionals are digging through client code bases, looking for architectural issues, bugs, DOS vectors, that kind of stuff. So while we're going to this multi-client phase, we have a lot of audits going on. So the audits need to be complete. We need to get some clean bills of health. And we're also launching an effort called Attack Nets, where in addition to this like multi-client testnet for people to get their feet wet and understand validation, we're gonna have a testnet running in parallel that we say like, please come and attack it, and put some bounties out there for that. So all of these things are kind of happening in parallel. We need to see success on all of those fronts, and then launch the deposit contract and get this thing out the door. I'm confident. Honestly, Altona, the current multi-client testnet, has gone really well. And my confidence is bolstered that these next hurdles are going to go well. We've actually seen some initial results in audits. Things are coming out pretty good. No crazy surprises there. And I've been saying this for some time. The last mile is long. There's a lot of little things. It's really crucial that we do it right, more than doing it on time. Just because Ethereum is a huge. It's a lot of value here. There's a huge ecosystem. There's a lot of people that are relying on this going well. So yeah, I'm not going to say a date, but it's coming together. It's feeling good. But again, I don't know how to respond.
Just one kind of procedural question. So the quote official multi-client testnet will have the same like basically parameters as Altona does, right? Because they're both mainnet equivalent. So what's the thing that stops literally launching the official multi-client testnet tomorrow?
I've been in conversations recently with teams. It's a couple things. One, there's still a couple of teams upgrading to Gossip Sub v 1.1, which hardens the Gossip protocol to a number of attack vectors. We'd really like to see this in testnets before we go to mainnet. And there's been talks about key management and standardization around key management in the past 2 months. And there's which really affects the UX of these things. And so there's some refactors going on in like command line tools and key management that people want to get out in the next approximately week and a half, so that the user experience of being on this next multi-client testnet is as close to mainnet as possible. So those are the two things, and running Altona for a week or so. This other thing is we have this what we call Launchpad. That's like a educational web interface that also allows you to make deposits. This is ready and planned to be launched for the next testnet, and we're doing some sanity checks and testing that against Altona right now too. So really, some of this gossip stuff and making sure the user experience is going to map well to the mainnet. I can take one more question and then I have to go because I do have something in 5 minutes, and I also am running the stream, and I'm going to have to stream the next thing I'm on, so I'm going to have to turn this off, which we've had a good run at 55 minutes at this point. Do you have one more question?
And I saw in the chat people asking about kind of ETH3 or what I call ETH 2.x and ZK Snark. So, and I can answer that for a couple of minutes too.
Yep.
Yeah. Okay. So basically, the kind of longer term goal behind this is the thing that I call ETH 2.x. So this is kind of more incremental protocol changes after ETH 2. So I'm expecting at this point it's likely that kind of ETH2's form of sharding kind of will be basically kind of the final form of the Ethereum protocol, but there will be a kind of changes that happen in a lot of different components. And one of the big ones that has to do with using zero knowledge proofs to make processing the blockchain kind of more secure and more efficient. And so this basically has to do with using things like ZK Snarks to just verify like state transitions, right? So just to verify that beacon blocks were created correctly or the shard blocks were created correctly. And so instead of like everyone having to either verify it themselves or trust a kind of relatively less robust scheme based on, committees or fraud proofs, there would just be one node that generates a big proof that just says this thing is correct. And then that proof can be very quickly verified by every other node in the network. So there's a lot of different places where this kind of idea can be applied. So like, for example, we've been having some discussions lately about applying it in the context of the beacon chain state transitions and trying to kind of allow beacon blocks to be kind of proven more so that nodes don't have to do the fairly expensive work of processing some of them. In the shard case, and the main challenge there is basically that kind of the bulk of the complexity has to do with the EVM. And general purpose virtual machines tends to be harder to zero knowledge proof than other things. But there has been a huge amount of progress on that made in the last probably 6 months. And so I think we're confident we'll eventually figure something out there too.
ZK, all the things.
Okay,
again, I have to run. It was a pleasure talking with all of you, and to all of those on the internet. Appreciate you all listening in.
It was so fun.